Hey guys, what's up? Hopefully you're having a good day. Taking a look at limits of multivariable functions here. We've got a limit as xy goes to 0, x to the 4 minus 4y squared over x squared plus 2y squared in the denominator. We want to see if this limit exists. If it doesn't exist, we need to show that it doesn't exist. So we're going to have some work cut out for us either way. Let's take a look at our strategy. Our strategy, first of all, is just to substitute in the point if the function's continuous, because if the function's continuous, the limit at that point is just the function value. So number two, if that doesn't work, if the function's not continuous, well, maybe it still has a limit, or maybe it doesn't have a limit. Well, the next thing we need to do, or the next thing we try, is just to show that the limit does not exist there. And we can do that by showing that through two different paths to that point, we get different limits. We'll see that here in a second if this is the case. And then number three, maybe we've kind of struggled with both of those, but maybe polar coordinates can help us out. So we'll look at an example later on of when we can switch to polar coordinates and show that the limit exists. And then maybe we'll look at showing that a limit does not exist with polar coordinates as well. So let's check this one out, see what happens, see what we can do. Let's try to show that the limit does exist, first of all, by just plugging in the point. Can we just plug in the point 0, 0 to this function? Well, if we plug in x equals 0, we get 0 right here. Y equals 0, we get 0 right here. So the numerator is 0. If we try to plug in the denominator, we get 0 plus 0. That's not good. So this function is undefined at 0, 0. This, not just because the numerator and denominator are both 0, but actually just because the denominator is 0 at this point. The function is undefined, so this function cannot be continuous here because it's not defined at 0, 0. So no, I can't just plug in the point. And now, okay, let me try to see if the limit doesn't exist maybe. Let's try going through different paths to show that the limit doesn't exist. So try number 2. So we're going to try different paths, and the paths that we generally try through the origin are x equals 0. That's the y-axis. Or we try y equals 0. That's the x-axis. Both of those go through the origin. Let's try y equals x. And then y equals x squared. Maybe x equals y squared. And maybe y equals x cubed. Or y equals square root of x. You know, these paths that go through the origin. Now, we're only going to need a few of these if the limit doesn't exist, because hopefully one of these will give us that the two different paths give us two different limits. So let's try x equals 0. So if x equals 0, then we would get the limit as 0 comma y goes to 0 comma 0. So we're basically just substituting in x equals 0. So that's 0 minus 4y squared over 0 plus 2y squared. That gives us, well, let's see, this is really just the limit as y goes to 0 of this function. So limit as y goes to 0 of negative 4y squared over 2y squared. Now we can actually reduce this because y is not 0. It's approaching 0, but it's not 0, so we can actually cancel these two y terms here. And this just gives us a limit of negative 2. So the limit as x equals 0 is really just negative 2. Now let's look at the limit as y equals 0, so approaching along the x-axis. So if we plug in y equals 0, look at the limit. Limit as x comma 0 goes to 0 comma 0. So basically that's just saying x goes to 0. Then we would get x to the 4 over x squared, because the y terms are both 0. So if we plug in y equals 0. Now, taking the limit as x goes to 0 of, I can cancel this out, just x squared. Where does x squared go as x goes to 0? Well, that goes to 0. That's just a parabola going to 0. So actually we have two different paths that show different limits. Therefore, the limit does not exist. So this means the limit does not exist. So these are not equal. Therefore, the limit does not exist. So that's pretty cool. And let's look at this same example, but let's show with polar coordinates that the limit does not exist. All right, so if we try polar coordinates, we would take the limit as r theta goes to 0 theta. Now, theta, we don't know where that's going to go, but we do know r is going to go to 0 because x and y are both going to 0. So your radius or your radial variable is going to 0 as x and y both go to 0. So let's substitute in what we got for x and y in terms of r and theta. So x is r cosine theta, so that's going to be r to the 4 cosine to the 4 theta minus 4r squared sine squared theta over, now x squared plus 2y squared. That's really x squared plus y squared plus y squared. So actually we could just write that as r squared plus r squared sine squared theta. So that's pretty cool. Now what can we do is do some algebra first of all, and we'll say that this is the limit as r theta goes to 0 theta. And cancel out an r. So r can cancel out here. We can cancel this. And then make this a 2. So this is really the limit of r squared cosine to the 4 theta minus 4 sine squared theta over 1 plus sine squared theta. All right, so now what we can do is break this numerator up into two different terms. Why do we want to do that? Well, because as r goes to 0, this first numerator term is going to go to 0. So actually we could just state that here directly. As r goes to 0, this term is going to go to 0 because it's got an r squared on it. Now the rest of it only has theta in it. So this leaves the limit as theta goes to theta negative 4 sine squared theta over 1 plus sine squared theta. Now this is a problem. This is a problem because when theta changes, which it's free to do because there's no restriction on where theta is going, only r goes to 0, theta can do whatever it wants, and r can still go to 0, and we would still be calculating the correct limit. As theta goes to whatever theta wants, it can be different values. So this thing is going to have different values for different values of theta. So this limit does not exist because these function values change with theta, and theta is free to be whatever it wants. So is not unique number. Therefore, the limit does not exist. So that would be a way to show with polar coordinates that the limit does not exist.